ማራኪ አካዳሚ የዩትዩብ ቻናል።
ሰላም ጤና ይስጥልን የማራኪ አካዳሚ ዩትዩብ ቻናል ቤተሰቦች፣ ይህ ማራኪ አካዳሚ ነው። እኔም የወርክሽት መንግስቱ ነኝ። በዚህ ቪዲዮ ይዘንላችሁ የቀረብነው ለፍሬሽማን ተማሪዎች ቤዚክ ማቴማቲክስ ፎር ሶሻል ሳይንስ ወርክሺት 2 ይሆናል። ከቻፕተር 2 አብራችሁን ቆዩ። ኦኬ የመጀመሪያው ጥያቄ ስለ ሪሌሽን ይሆናል and the functions, relation and functional. So when we say that the relation, so we must be considered the Cartesian product of two sets. Any subset of the Cartesian product of the two sets A and B is said to be the relation, which means for we can consider that two sets. Let the sets A and B. So we form the Cartesian product of two sets, which means the correlation of the order pair within the sets say that A must be an element in the set A and an element B must be the set of in B. So any subsets of this Cartesian products is said to be the relation R. So we form the relation from A to B. Now our target is to determine for the relation is said to be functions. If the relation is a functions, then we can consider that if the relation R is a functions which must be satisfied, if and only if this must be satisfied the conditions. If the relation is a function from the set A to B, so this relation must be satisfied these two conditions. First, the domain of the relation must be all elements in the set A, and second, no element in the sets A assigned to B more than one element. More than one element in the sets B. ይህን ሁለቱም ኮንዲሽን የሚያሟላ ከሆነ ሪሌሽኑ ፋንክሽን ነው መሆን ይችላል ማለት ነው። Now, so we have for the function, for the relation. So from the relation A, we have this. The first element with the order pair W with 3 and X with 4 and Y with 5. We have this relation. Now, this relation must be satisfy these two conditions if this relation is a functions. So first of all, it must be determined what the domain of R. So the domain of R is the all element in the first coordinates. What the domain of R? For this, we must be the collection of the first order, which means W, X, and Y. So the domain of this relation is W, X, and Y. But this set is not the same as the set in A. The set in A is W, X, Y, Z. So having this element W, X, Y, and Z. So one element D is not assigned to B in for every element in the set B. Therefore, the domain of R is not all elements in the set A. Therefore, we conclude that R is not a function. Rን ፋንክሽን አለን ብለን መውሰድ እንችላለን ማለት ነው። ምክንያቱም የመጀመሪያውን ክራይቴሪያ አያሟላም ሪሌሽኑ ፋንክሽን እንዲሆን። Now for B ላይ for the relation B which containing these sets, the first W with 3, X with 4, Y with 5, Z with 5. So we have this relation. Now we need to check the first criteria. What the domain of this relation are? The domain of this relation are is the collection of the first coordinates, which means W, X, Y, and Z. Yeah. So this is the same as the set A. The set A containing all elements on X, W, Y, and Z. So the first criteria hold. what the second? When you observe the relation R, the set A, every element in set A assigned to no more than one element in the set B. Therefore, we conclude that our relation is a function. So we can consider every element in the set A assigned to no more than one element in B. Yeah, so these two criteria hold for this relation, hold these two criteria. So we must be conclude that the relation R is a function. Relation R function ነው ማለት እንችላለን. Now, for the C, the relation R containing this element W 3 and X with 3, Y with 3, and Z with 3. Yeah. So when you observe this, what the domain of this? The domain of this relation is the all element W, X, Y, and Z. This is also the same as the set A. So the first criteria hold. What the second? When you observe the first coordinates W, X, Y, and Z, each element is assigned to no more than one element in the second coordinate. Therefore, we conclude that our relation is a function. So each element in the set A assigned to no more than one element in B. So these relations hold these two properties. So you must be conclude that the relation is a function. The relation is a function. So in this case, in general, we must be consider the relation R having some order with X and Y. Relational function ነው የምንለው just see the real life ውስጥ መውሰድ እንችላለን። አሁን ለምሳሌ የቤተሰብ ዝምድናን የእናትና የልጅ ዝምድናን we must be consider Xን እንደ child ውሰዱት። this is Y ደግሞ እንደ parent. yeah so ይሄ ዝምድናቸው X as a child, Y as parent. አንድ ልጅ ግድ አንድ አባት ነው ሊኖረው የሚችለው ሪሌሽን ፋንክሽን እንዲሆን። ነገር ግን አንድ አባት ሁለት ልጆች ሊኖሩት ይችላሉ። አሁን እዚህ ጋር አንድ አባት ሁለት ልጆች ሊኖሩት ይችላሉ ማለት ነው። ሪሌሽን ኢዝ ኤ ፋንክሽን። በዚህ ጋር አሁን 3ን ብንወስድ 3 ከW ጋር ማፕ አድርጓል ከኤክስ ጋራም so the first coordinate having, it's possible to say the first coordinate having more than one, the first coordinate, the second coordinate having more than one first coordinate if the relation is a function. Look, X as a child, Y as a parent. አንድ ልጅ አንድ አባት ነው ግድ ሊኖረው የሚችለው። አንድ ልጅ ሁለት አባት ሊኖረው አይችልም በሪያሊቲ። ስለዚህ በዚህ ሪሌሽንን ወደ ፋንክሽን ስንቀይር እችን ኤግዛምፕል ማየት ትችላላችሁ። so in this case our relation having a function, ሪሌሽኑ ፋንክሽን ነው ማለት እንችላለን። ኦኬ ዲ ላይ now W with 3, X with 5, Y with 4, and Z with 3 and Z with 4. Okay. Now, what the first criteria? What the domain of this relation R? The domain of this relation is W, X, Y, and Z. Yeah, it's repeated. So we can take one of them. So this is the same as the set A. So the first criteria hold. For second, when you observe the first coordinates W, X, Y, and Z, these are assigned to more than one element in the second coordinate. Therefore, in this case, our relation is not satisfy the second criteria. Meaning, there is one element. There is one element in the set A assigned to more than one element in set B, which means we can take this. Z is an element in the set A. This assigned to both for what? 3 and 4. Yeah, like አሁን ዚ የሚባል አንድ ልጅ ሁለት አባት ኖሮ ማለት ነው። ስለዚህ በዚህ ኬስ ሪሌሽኑ ፋንክሽን መሆን አይችልም ማለት ነው። ሁለተኛውን ክራይቴሪያ ስላላሟላ። therefore we conclude that the relation R is not a function. ሪሌሽኑ ፋንክሽን አይደለም ማለት ነው። ኦኬ አሁን ደግሞ ወደ ሁለተኛው ጥያቄ እንሂድ። የሁለተኛው ጥያቄ for the domain and range of the relation. So for any relation from the set A to B, so we need to determine for the domain and range. So it can be written as it is. So the collection of the order pair with an x and y, say that x must be an element in the set A and y must be an element in set B. So every collection of the first coordinate is said to be the domain of the relation R. For the first coordinate, every collection of the first coordinate is the domain of R. And the second coordinate is the range of R ነው ማለት ነው። የመጀመሪያው ኮኦርዲኔት እንደ ዶሜን ነው የምንወስደው፣ ሁለተኛውን ኮኦርዲኔት ደግሞ እንደ ሬንጅ ነው የምንወስደው ማለት ነው። ሬንጅ እና ዶሜን ዲተርማይን ለማድረግ ኦኬ ሶ our relation A ላይ R which is having this order R with delta and 3 with R and 3 with 7 አለ። So from this relation what the first coordinates are 3 and 3 ነው። So the domain of this relation R is the collection of the first coordinates R and 3 ነው ማለት ነው። And the range of this relation R is the collection of the second coordinates, which means the collection of all second coordinates delta R and 7 ነው ማለት ነው። ይሄ ነው range and relation ነው። What about the B ላይ the relation which is containing this element? So this is an element in the Cartesian product of real number with real number. አሁን this relation is a subset of the Cartesian product of real number with real number. Now, so we have some properties. Y which is equal to ln of x minus 2 አለ ማለት ነው። አሁን ሪሌሽናችን any subset of the Cartesian product of real number with real number then which must be satisfied this property y which is equal to ln x minus 2 የያዘ መሆን አለበት ማለት ነው። ኦኬ ይሄን ለመስራት ምንድነው የምናደርገው? first we need to sketch what the graph of this. So first of all, what about the domain? The domain of the relation S should be x, the collection of x when x must be greater than x minus 2 must be greater than or equal to greater than of 0, which means which is the same as x is greater than 2 ነው ማለት ነው ዶሜናችን። ስለዚህ so on the we have the vertical asymptote on the x which is equal to 2 ላይ vertical asymptote አለ x which is equal to 2. Yeah. Okay, when we sketch the graph as x is approached to 2 on the right side, the graph is passing in the or which is goes to negative infinity. Now, so what the x-intercept? There exists x-intercept by making what? Y which is equal to 0. Y in 0 አድርገን x ስንፈልግ ln of x minus 2 which is equal to this can be expressed by e raised of 0 which is e raised of ln of x minus 2 ማድረግ እንችላለን። so this is the same as e raised of 0 that's 1 ነው which is equal to x minus of 2 ነው. so this implies x which is equal to 3 ነው ማለት ነው. so the x intercept of this the graph of this function is at 3 ላይ ነው ማለት ነው. so as x is approached to 2 on the right side the graph is approached to negative infinity like this. as x is approached to infinity so the graph is moved to in this direction. so depend on this graph we determine what the range of this relation. so range depend on this line. so the range is satisfy the value of y የy value ነው የሚይዘው range second coordinate ነው የሚይዘው። ስለዚህ የy valueችን touch for any point at y. ስለዚህ the range of this is said to be all real number ነው። range all real number ነው. the domain is x must be greater than 0 which means x is from 2 is not touch at 2 up to infinity ነው ማለት ነው። ከሁለት ወደ infinity ድረስ የሚሄደው ማለት ነው። this is the range domain and the range of the relation S. okay አሁን for C we have the relations can be defined by the collection of the order pair xy. this must be an element of the Cartesian product of A with B and this hold these properties. x must be greater than y. where we have the set A which is containing this element 0 1 5 and 7 ይዞልናል. then set B ደግሞ which is containing -1 6 and 8 አለ ማለት ነው። ስለዚህ ማንኛውም the subset of the Cartesian product of A with B ለዚህኛው ሪሌሽን ፎርም ማድረግ ይችላል። ነገር ግን we have some restriction here. x must be greater than y መሆን አለበት ነው የሚለው። ስለዚህ we have generate the relation ከዚህ ሪሌሽን ሴቶቹን ዲተርማይን ማድረግ እንችላለን። so now form the relation from this set A to B which hold these properties. what the first coordinate must be greater than second coordinate. okay so when form ስናደርግ 0 with -1 satisfy the conditions condition ያሟላልናል. so 0 is possible to pair with 6 no because 0 is not greater than 6. ስለዚህ 0 ከ6 ጋር ከ8 ጋራም አሳይ ማድረግ አንችልም። 1 with -1 yeah 1 is greater than -1 satisfy ማድረግ ይችላል. now 1 is possible to assign with 6 no because 1 is not greater than 6. so 5 with -1 yeah possible 5 with -1 because 5 is greater than -1. is it possible to assign with 5 with 6 no because 5 is less than 6. okay what about 7 with 6 yeah possible yeah first of all what about 7 with -1 possible 7 with 6 yeah so this is only the element of this relation R. እነዚህ ናቸው ሪሌሽኑ. this is a subset of the Cartesian product of A with B. okay from this we determine what about the domain of the relation R to T. so the domain is the collection of the first coordinates yeah which means 0 1 እና 5 7 ናቸው ማለት ነው first coordinate. okay እነዚህ ናቸው and what the range of T is what the second coordinate -1 እና 6 ብቻ ናቸው ማለት ነው first coordinate. okay this is only the domain and the range of the given relation.
የሶስተኛው ደግሞ ስለ relation and inverse relation ነው. we have the relation by set building method like this. the relation R which is defined by for the collection of the set order pair within xy. xy is an element of the Cartesian product of real number with real number then which must be hold this property. now So how to find, first we need to find the graph of this relation. So to sketch the graph, we must be consider what? The collection of the order pair within the real number with real number. But must be, this condition must be held. What the value of x must be between 0 and 1, and the relation must be hold this equation, y which is equal to a raised of x. So we must be draw what mean the graph of this line, this curve. So if x is 0, the value of y e raised of 0 becomes 1. So the value of y is at this point, 1. If x is 1, the value of y becomes e, which means between 2 and 3. So somewhere here we have the value of e for the value of y. So the collection of each point in this curve is said to be hold the property of the relation. So all order pair which is lies on this line is said to be the element in the relation. So this point is 1 and e. At this point is we have 0 and 1. Now, so as shorts, this relation containing the all points within that element, we can take 0, 1, and 1 is also an element in the relation R. The relation R ማለት እንችላለን. Now, so this implies, in according to the inverse relation, so we will change the order of the first and second order. So the all element in this 1 with 0 and e with 1 is also an element in the inverse relation. So in general, to define the relation in this set building, so take as xy, which is an element in this relation R, then this, and the value of this will be changed. So y which is equal to e raised of x. To find the inverse of this function, we must be interchange the variable of x and y. So this becomes what? X, which is equal to e raised of y. Then when we apply ln both sides, we need to find the value of y. So we apply both sides ln. So ln of e raised of y, this becomes ln of x, which is equal to, in according to the rule of ln, this becomes y. So y which is equal to ln of x is the inverse of the given equation. So here we have this. Then we must be determine the value of x is between 1 and e. So this, the values becomes 1 and e. X is between 1 and e. And this equation becomes y which is equal to ln of x ይሆናል ማለት ነው። So የዚህን ግራፍ ለመስራት ይሄ ኢንቨርስ ሪሌሽኑ ነው። ግራፉን ለመስራት depend on the values. When x is becomes 1, what the value of ln 1? That's 0, no, at this point. So this point is we have 1 and 0 if x is 1. If x is e, ln of e becomes 1. Somewhere we have the value of 1, the value of y is 1. So the whole collection of this order is said to be the graph of inverse relation. This is the whole collection of this is said to be the graph of inverse relation. So this is said to be R inverse. So this is the graph of the R inverse. This is the formula for R inverse of a given relation R. Okay, thank you. Okay, የአራተኛው ጥያቄ ደግሞ ስለ composition of relation ነው. So here we have two relation R and S. How to find S composed R and R is composed S. So now to do this, for the relation, A line, R having the points 1, 1, 2 is 2, and the relation S containing this order pair 2 is 4. Now, to do for what about S composed R? Which means we need to draw for the set Venn diagram. So here having the relation from R with S, so this is for the relation R, which is mapping to this relation, say S. Now the relation R having the domain is said to be 1 and 2. So when you R is the domain R having this range becomes 1 assigned to 1. So this is having this point. Then in the same way, 2 is also assigned to 2. 2 is assigned to 2. Now in these compositions we have here S of R, which means S of R at point, which can be expressed by S of R at point 1, the value of S, the range will be what? 1, right? So we have 1 here. So what about S at point 1? S at point 1? No. So there is no, the domain of S is at 1. So we can shift this point is not mapping to the relation S. So there is no any element which is assigned to the set of this. Now the other is if S of the R at point 2, what the range of this R at point 2? 2. So this having this point. So now we can consider this R at point 2 now. So what about S at point 2? S at point 2 having assigned to 2 different elements. So 2 which is assigned to the element 3 and 2 is also assigned to the element 4. So this relation having this point 2 with 3 and 2 with 4. So this is the all element of S composed R. In the other ways, R composed S. So as a Venn diagram, we can consider this. Then what the elements in the set S, what the domain of the set S. The domain of the set S is containing only 2. Then the range is we have 3 elements in the set S. So this is 4 and 3. Okay, now what about this? R composed, this is the set S at point 2. The values becomes what? At R at point 2, 3. So this is mapping from this. What about the element here? No. So no element in the range of this element. So there is no any element. So this is not composed in the relation R. So what about the other is R at point S at point 2. So also there is no element in the range, which means R at point 2, the values becomes 4. So now the domain element in the relation R. So this relation having no element. So the relation is containing empty. So this is there is no any element in this relation R composed with S. For B, this relation containing 1 with 2, 1 with 3, 2 with 4, 5 with 7, and this relation having this 2, 3, 2 with 4, 3 with 5, and 7 with 1. Okay? So using the same way, what about the S composed R? Using the Venn diagram. So what the relation in this, what the domain of the relation R? The domain of the relation R containing 1, 2, 5. Okay. Now to do this, so S of R at point 1. What the values are at point 1? In this case, we have 3. S at point R at point 1, we have 2. Then when you are assigning, what about S at point 2? S at point 2, 3 and 4. So at point 1 line, which is mapping at point 1 line, this is can be mapped to the at 2. So these two assigned to two different variables, so it's 3 and 4 normal, which is assigning to 3 and 4. So this because the values becomes 3 and 4 in this case. Okay, what about R at point 2? So S at point R at point 2, the values becomes what? R at point 2, the values becomes 4. So what the value of S at point 4? No, there is no any element which is mapping to this set. So 2 assigned to 4, but it is not mapping in the set S. So this is the relation for S, R. This one is for S, which is mapping this 4. Okay, the other is S, R at point 5. S at point R at point 5, the values becomes 7. Now, what about S at point 7? S at point 7, 1. So this is mapping in the 7 here, then this is also mapping in 1. So we have this is as a composition. Now the other we can form it as S of R is the collection of what? 1 with 3 and 1 with 4. The other is when 2 is nothing having the element in the S. The other is 5 with 1. This is an element of the composition with SR. What about R composed in S? Using the same way. What about the composition in S? We have 2 and 3. Okay, so R at point S at point 2, what the values? 2 and it's also 7. Huh? Okay, R at point S at point 2, R at point 3, no? This values. So 2 is mapping in 3. So what about R at point 3? R at point 3, is there any element for the element in the domain? No. So it's not assigning for 3 is not assigned to S. The other is R at point 3, S at point 3. What these values? S at point 3, the values becomes what? 5. So here we have 2 is assigning in the 2 elements, 2 is assigned to 3 and 4, but 3 is assigned in 5. This is all element in the domain, 2 for this compositions. So we can contain this and S at point 3, S at point 3, what the values becomes 5. So 3 is assigned by 5. This is R at point 5 is what? No, R at point 5, the values becomes 7. So this 7 is 3 with a mapping to what? Okay, so Rizika. For the composition S, 2 is mapping in 3 and 4. Okay, what about is there any element in the domain for R at 3 and 4? No, there is no any element. So we cannot assign this element. The other is 3 in the set S. Thus, the result becomes 5. Yeah. Is there any element in the R as a domain? Yeah, 5. 5 can be assigned in this element. That's 7. 7 is an element of in the domain of this. Okay, yeah. Okay. The other is R at point S of 7. What about S at point 7 at the domain? The values becomes 1. The result becomes 1. Yeah, this is S to R. Okay, so what the values? R at point S at point 7, the values becomes 1. So this result becomes 1. So what about R at point 1? R at point 1 having 2 elements, which are assigned to 2 and 3, which is assigned to 2 and 3. Is that? Yeah, 2 and 3. So this one is mapping in 2 and 3. So what are our compositions? R circle of S, which is equal to our composition becomes, which is containing 2 mapping with, there is no any element, 2 is mapping 2 for this element, so 3 with 7 and 7 with 2 and 7 with 3. Yeah, this is the all element in our composition function, which is all element in the Cartesian product of real number with real number when the function must be defined as it is. And the set S, the relation S, having this element, which is the Cartesian product, and x over x minus 2. Okay. What mean the S composed in R? So within the same way, we can form the value of x in this relation, S of R of x, which is defined by what? R of x at the result will be defined by these functions. So we must be defined at that expression. So S into can be, this result is having the value of y. The value of y can be expressed by 1 over x minus 1. So this can be expressed by x 1 over x minus 1. Now, this is the result for in the set S. So the set S, which is containing s, x, and y, but y is defined in this relation. So we must be, in terms of x, we must be substitute this all expression. So this becomes 1 over x minus 1 over 1 over x minus 1 minus 2. So this is becomes 1 over x minus 1 over, this is becomes minus 2 times x plus 2 over x minus 1. which as a common ወስዳችሁ መስራት ነው ይችኛዋን expression, which means 1 over x minus 1 minus of 2 can be expressed by the as the common x minus 1, which is becomes 1, x minus 1 divided by x minus 1, 1 times 1, 1 into x divided by this 1, that's x minus 1, x minus 1 times this minus 2, x minus 1. This the result becomes 1 minus 2 times x plus 2 over x minus 1. So this result becomes 1 over x minus 1 over this is 3 minus 2 times x over x minus 1. So this can be cancelled out. We have 1 over 3 minus 2 times x. So our decomposition functions can be defined by, as it is, the all collection of x, y, which is an element of all real numbers, Cartesian product of real number with real number, say that y can be defined by, within this expression, over 3 minus 2 times x y. Okay, so as a composition, we have this form. In the other form, in the other ways, to find S circle of R, like S of, okay, in this case, R circle of S, so we need to find R at the points S of x. So this is the same as R at points, the function f at S at point x, we have the result becomes x over x minus 2. Okay, so now what about the value of R? We have xy, which is an element of the Cartesian product, y which is equal to defined by as it is. So in terms of x, we need to substitute the whole expression in this form. So the result becomes 1 over, in terms of x, we substitute x over x minus 2 minus 1. So this becomes 1 over x minus 2 over x minus of 2. Now we have this, then when we subtract this, we have get minus 2 over x minus of 2. So this is becomes, this becomes 2 minus of x over 2. Therefore, R circle of S can be defined by a set building x of y, which is an element of real number with real number, this is the Cartesian. Say that y which is equal to 2 minus of x over 2. This is our the Cartesian product of this composition. Okay, in question number 5, here we have two sets A and B. Then we need to form the Cartesian products of all elements in the set A and B. And from the Cartesian products, we need to determine the all subsets of the Cartesian product. Means finding the relation from A to B. And last, we need to find from the all elements in the relation, we select which are a function. Now, what mean here the relation, the Cartesian product of A with B, which is defined by the all element of the order pair, say that A must be an element in the set A, and the element B is the second order is an element under a Cartesian product ማለት within the all element of the order pair, the first element is the set A and the second element is set B. From those or sets A and B, we need to form the all Cartesian products, all the Cartesian products. So take the first element, say 1 can be assigned with to T, and the other 1 also assigned with S. This is all. Then second, the element 2 can be assigned with in the second order within the set B, and 2 is also assigned with S. Yeah, this is the all Cartesian element of the given sets A with B. From those elements, we need to determine the relation, which means the relation R is relation R from the set A to B is the all subsets, any subset from the given the relations, which means the relation R is the subset of the Cartesian product of B. So all subsetoችን determine ማድረግ እንችላለን from this set. So the first relation R1 is also the first element. This is also the subset of this set. Yeah. So what about the others? R2 line. This is also having one element, say 1 and S. This is also subset of in this relation within one element. So R3, 2 is T. This is also subset in this relation. The other R4 having 2 is S. So this is also subset for a given relation R. R5 within two elements, two orders. Take 1 with T and 1 with S. This is also subset. R5, 6. Okay. 1 with T and 2 with T. And the other is R7, which becomes 1 with T and 2 with S. Okay, so this can be assigned with these all element. So we can order as it is. So R is ደግሞ it can be assigned with 1 with S and 2 with T. This is also subset of this element. R9. Okay, also the orders 1 with S can be assigned with 2 with S, and the other is R10, which is having this order. It's possible 2 with T and 2 with S. This is the other subsets. The other is R11. We have 3 elements, so we can take 1 with T and 1 with S and 2 with T. This is also subset for a given relation R, the Cartesian product of A with B. The other is, we can select this also, 1 with S and 2 with T and 2 is S. This is also the others. So what we have, the others are 13. Okay, what we have left here, okay, from these 2 and this, then this from this element, we can form 1 with T and 2 with T and 2 with S, possible. Okay, the other is, this is can be assigned with these 2, possible, yeah. R with 14, which is for which element? Okay, 1 with T and 1 with S and 2 with S. Yeah. So this is not repeated, yeah. This is S, this is not 3. So this, and the other is all elements. 15. The other is all elements. The set Cartesian product. 1 with T, 1 with S, and 2 with T, and 2 with S. This is the all element with the 4 elements. The other is the empty set. The empty sets also subset. So we have the set A containing 2 elements, set B containing 2 elements. So we have how many? The number of set A times the number of set B. So this is 2 raised to 4, which is having 16 relation we form. Now from those elements, which are the function, this is all the relation. So to determine the function, from this relation to determine the functions, so first we must be consider the criteria of the relation itself to be a function. ምንድነው? The all domain must be the set of in A መሆን አለበት, and for every element in the set A must be assigned to no more than 1 element in set B መሆን አለበት. So which is satisfy these 2 conditions. Yeah, R1, R2, R3, R4 is not satisfy the first condition because the domain is only 1 for and 2. So it's not satisfy the first condition. Then R5 and R6 and R7 is also not satisfied because 1 is mapping to 2 distinct elements, T and S. Here also, it is possible for R6, R can be assigned was T and T, so yeah. So R6 R6, which is containing for which element? 1 with T and 2 with T. Yeah. So here function መሆን ይችላል። ዶሜኑ 1 እና 2 ነው። the set A ነው. Then 1 is mapping to T now, then 2 is also mapping to T. So this is also a function. What about R7? R7 here 1 is T, yeah. R7 ላይ 1 with T and 2 with S. Okay, this is a relation. Yeah, the domain is 1 and 2. 1 and 2 is also an element of the set A. Then each element in the first coordinates is assigned to no more than 1 element. Yeah, so this also as a function. In function ማለት እንችላለን. Now R8ን check out. What about R8 here? Yeah, this is as 1 with S and 2 with T. Yeah, this the first domain is all elements in the set S, the set A. So each the first coordinate is mapping to more than 1 element, so this satisfy as a functions. What about R9? R9 ስታዩት, yeah, having this is also as a relation, as a functions. So 2 with S. Yeah. So first domain all elements in the set A now, and the first coordinate mapped with distinct element. Okay. So therefore, what about R10? R10 ላይ it's not as a relation is not as a functions because 2 is mapping to 2 distinct different element. So it's not as a function. Function መሆን አይችልም. What about 11 is? It also is not a function because one is assigned to two distinct elements, T and S. Function መሆን አይችልም. Him 2 is assigned to two distinct elements. Function መሆን አይችልም. R13 it's not as a function because 2 is assigned with two distinct elements. What about here? This also is not as a function because one is assigned to T and S. Not satisfy the second condition. This also is not as a function. So the other is, what about this is as a function? No, because there is no element in here because the domain is not all element in the set A. So the only the relation as a function is this one. The only relation as a function is R6, R7, R8C, and R9. Okay? Thank you. ኦኬ ቤተሰቦች የዛሬው ቪዲዮ ይሄን ይመስላል። የተለያዩ ጥያቄዎች ካላችሁ ኮሜንት ላይ አስቀምጡልን። ለቻናላችንም አዲስ ከሆኑ ላይክ፣ ሼር፣ ሰብስክራይብ ማድረጋችሁን አትርሱ። ቀጣይ ጥያቄዎችንም በቀጣይ ቪዲዮ ይዘንላችሁ እንቀርባለን። ሰላም ሁኑ።